Hello everybody, here we are 1.2 squares and square roots. We'll start with a few definitions and I will type them so you don't have to read my writing. So a factor is a number that divides evenly into another number. So you can think about a number that divides into a number and there's no remaining numbers. So I will show you, for example, the factors of 16 are, okay, so these are the numbers that can divide evenly into 16. So I know that 1 and 16 divide evenly into 16. They both go in there without any remainders. It's an even number, so I know 2 goes in there. And half of 16 is 8, so I know it's going to be 2 times 8 goes in there. 3 does not go in there, but 4 does. And then 5 does not divide in there, 6 does not divide in there, and 7 does not divide in there. So these 5 numbers are the factors of 16, the numbers that divide evenly into 16. Okay. Next we have squares. Okay, we've been learning about square numbers, and it is, I'm going to type it. Let me not forget. So it is a square number is the result of multiplying a whole number by itself. Okay, so let's see some of our square numbers. Let's say 4, 9, 16 are square numbers because 2 times 2 equals 4, 3 times 3 equals 9, and 4 times 4 equals 16. Okay, so they are all the results of multiplying a whole number, so not a decimal, not a decimal, but a whole number, 2, 3, 4 are counting numbers by itself. Okay, and finally, we have this thing called a square root. And this definition, I think, is going to be a little clunky. It's kind of the best I can do, but I hope as we go on more, if we learn it more, and I give you few different ways to think about it, it'll make more sense. So a square root is a value that, let me write this down in my, okay, so is a value that when multiplied by itself gives the original number. So let's see, the square root of 9 is 3 because 3 times 3 equals 9. So it is a value that, when multiplied by itself, gives the original number. So in this case, our original number is 9. And when we find the square root of it, so when we find the square root of 9, we get a number that, when multiplied by itself, yields our original number. Okay. I find definitions can be a bit clunky, but hopefully as we go on, we'll get some better examples and I'll show you. And you can think about this. One thing that's important for us to remember and always think about is that it's an inverse operation to squaring something. So it's an opposite operation. You could think of the square root as almost like an origin story or something like that. So next we are going to find the answers to these questions. And when we see this little 2 here, a number raised to a little 2, we call that being squared. And this is called an exponent. And maybe I will draw this for you. 6 to the power of 2. This is called an exponent. And when it's a 2, we say the word that it's being squared. Because remember from all of our really nice pictures and examples we did in the last in 1.1, we were drawing a lot of squares and we're thinking about it being squared, and that's where that little exponent of 2 comes in. So this means that we have 6 times itself twice. So we have 6 times 6. 6 times 6, as you recall, is 36. Here, when we have 11 squared, or 11, we sometimes call it to the power of 2, that means we have 11 times itself twice. So 11 times 11, which we know, and we can use our chart to show us that it's 121. Finally, when we have 5 squared, that means we have 5 times 5, which you can, you're welcome to do this in your calculator or on your multiplication chart. We know 5 times 5 is 25. Okay. So now we've squared these numbers. And now we're going to do the inverse operation, or the opposite operation, and find the square root of each number. So we're looking for a number that when multiplied by itself is going to equal 49. So we're looking for, question mark times question mark, and it's the same question mark, equals 49. Okay, so what we can do, if you have it on your calculator, there's a symbol for square root which looks something like this. That's not a very good drawing. Let me do it again. It looks like this. It's called a radical sign. And if you put 49 inside there, that means you're taking the square root of it. And I know that the number times itself that gives us 49 is 7. Okay, the next one I'm going to show you on a calculator. So we're looking for the square root of 64. So that's going to equal, let me go to my calculator here. I think that this has a square root button. So here we go. I'm going to go 64, and then I'm going to press this button right there, and it's going to give me the square root, or the thing that when multiplied by itself would give us 64, and that's 8. Here we have 196. Let's use our calculator again. So 196, and I can press this square root button right there. It's going to give us 14. So the square root of 196 equals 14. So that means, and that should be true, that 14 times 14 is going to give us 196. And is that true? Yeah, it is. Okay, so that's what that is finding. It's kind of finding like its origin story, where it starts out. So you're asking yourself what times itself is going to give us 196. Okay, let's move on. We need to list the factors of each number in ascending order. Okay, I think we were pretty good with the ascending, descending. Ascending means we're going up. Descending means going down. If you're descending the stairs, you're going down. If you're ascending the stairs, you're going up. So they want to write it in the order of smallest to greatest. So which numbers are square numbers? How do you know? So we're going to list the factors of 64. So I like to do what I call the rainbow method. So I start 1 over here, 64 over here. What else goes into 64? 2 and half of that, which would be 32. 3 doesn't go in there, but 4 does go in there. 4 goes in there, I think, 16 times. 5 doesn't go in there. 6 doesn't go in there. 7, not 7. 8 goes in there. 8 times 8 is 64. Then 9, not 9. Not 10. Not 11. Not 12. So I think that's it. And we've already listed them in ascending order. So I've already gone, least over here to greatest over here. Okay, and I want us to, it's going to ask us, how do we know? And I want us to do something, I want us to count how many factors there are. There's 1, 2, 3, 4, 5, 6, 7 factors. Okay, let's just put that piece of information away for a second, and let's do the factors of 70 next. So let's go 1 times 70. It's an even number, so I know 2 is going to go in there. It's going to go in there 35 times. 2 times 35 is 70. 3 does not go in there. 4 does not go in there. 5 does, because it ends in 5 or 0. 5 can go in there 14 times, I think. Let me just check that. 5 times 14 equals 70, yep. 6 does not go in there, but 7 goes in there. 7 times 10. And I think that's it. So now we have the factors, or the numbers that divide evenly into 70. And now let's count them. 1, 2, 3, 4, 5, 6, 7, 8. 8 factors. Okay, so for this number, which is not a perfect square, we have 8 factors. For 64, which is a perfect square, we have 7 factors. Okay. So what this, it's always going to be true, and maybe you should write this down on your notes. Maybe we should put this right here. Maybe I'll do another color. Is that perfect squares always have an odd number of factors. Okay, let's think about why this is true. This is true because think about, look, the 1 matches up with the 70. The 2 matches up with the 35. The 5 matches up with the 14. And the 7 matches up with the 10. That's even. But here we have the 1 match up with the 64. The 2 match up with the 32. The 4 match up with the 16. But then the 8 multiplies by itself. So you end up with this odd number of factors. So that's a way how you can tell by the number of factors if a number is a square number or not. Now it wants us to find a square root of each number in part A. So we can do a square root of 64. Let's do it in our calculator. 64, hit the square root button. That's 8. And the next one, since it's not a perfect square, we're going to end up with a decimal. We're not going to end up with a whole number. So let's go 70, square root button. Okay, 8.3666. Let's do 8.37. 8.37. Okay, so not a perfect square, does not have a full number or a whole number square root. Okay, let's do a few more. This one is, you got to really be careful with the wording. Find a number whose square root is 24. So it's not saying find the square root of the square root of 24. It's asking for a number whose square root would be 24. Okay, so that means that we're looking for a question mark that would have 24 times 24. Because that's what the square root is, remember? It's finding what times itself would equal that. So all we have to do is just go 24 times 24, and we get 576. We can check this answer. We can go 576 square root equals 24. So we know that to be true. Oops, 24. Okay, a few more. Find the square root of each number. Okay, they are trying to, this is tricky, okay? Find the square root of each number. So they're doing a kind of, we have to notice that it has to the power of 2 there. So we can't get fooled by these numbers. Okay, so this is actually saying what is the square root of 12 squared. So let's give it a go. Let's first solve 12 squared. So let's go 12 times 12, and that equals 144. Now let's find the square root. So what times itself would give you 124. So we can go 144, square root